Hello everyone, thank you for being here. My name is Maharshi and today I'm thrilled to present my project Market Volatility Prediction using AI and Econometrics model. This study is focused on understanding how volatility can be predicted using both statistical tools which are used traditionally and the modern artificial intelligence. Volatility refers to the extent of variation in stock prices. It is one of the key indicator of risk in financial market. The goal of my project was to compare the performance of two very different models, the traditionally Garch model and a deep learning based LSTM model, and then build a hybrid model that combines the strength of both. I collected the historical data from Yahoo Finance. I calculated log returns to normalize the data and handle the missing values. I first implemented Garch 1.1 model, which is widely used for capturing volatility clustering. Then I trained LSTM neural network using TensorFlows. Finally, I created a hybrid model by averaging predictions for both, aiming to increase the accuracy. The code is very user friendly. You just have to input the ticker of the stock. Now let's take an example of Apple. Daily log return of Apple. This plot represents day-to-day percentage change in price, which gives us a clear picture of volatility than price itself. You'll notice the significant spikes, especially during the crisis period, highlighting how volatile Apple stock can be in response to external shocks. Now to the third plot, Garch 1.1 volatility forecast. As you can see, volatility tends to cluster. Periods of calm are followed by turbulence and vice versa. The peak around 2020 again reflects the market panic due to pandemic. To dive deeper, the fourth plot shows the distribution of Garch estimated volatility. It reveals a right skewed distribution, meaning most days have low volatility, but there are occasional extreme spikes. This behavior is typically in financial time series data. Now let's compare that to modern AI. The fifth plot is of the distribution of LSTM predicting volatility. Unlike Garch, the LSTM model predicts a more symmetric distribution focused around a lower volatility range. This could indicate underestimation of extreme movement, a common limitation to deep learning models when trained on data with fewer high volatility events. Finally, the sixth plot compares actual volatility with LSTM predicted volatility. The black line shows the actual volatility with lots of noise and spike. The blue line, our LSTM prediction, is smoother and captures the general direction but fails to fully track the volatility spikes. This suggests that while LSTM can model regular market behavior, it struggles with rare extreme events. This model have real-world use cases, such as it can be used in trading firms to identify high-risk period and optimize entries and exits. In risk management, banks rely on them for stress testing and hedging, and even central bank look at the volatility before making the policy decisions. While building this project, I have considered the limitations such as Garch is limited by linear structure. LSTM models are like black boxes, harder to interpret and explain. And the prediction is based on the historical data, and our future is always uncertain. Therefore, the impacts like war or pandemic are unpredictable. And also looking ahead, there are many chances of enhancing this model as well, such as by integrating real-time news sentiment, we can respond to market mood more dynamically. Using transformer-based model might help to uncover deeper patterns in time series data. Finally, deploying this as a real-time forecasting dashboard could provide an actionable insight to investors and risk managers. To conclude, I'll say that this project demonstrates that by combining econometric model and artificial intelligence, we can build more powerful financial tools for volatility prediction. I would like to thank you all for your attention and interest. If you have any questions, I'm here to discuss now. Thank you once again.